Welcome to today's video. We are going to be going over 1.3 and 1.4 notes. 1.3 notes is a continuation of the last ones, except we're just going to be working with the calculator to graph things. And then 1.4 notes is graphing or is estimating limits using tables. So how we're going to start off is you need to have a TI-84 calculator for this lesson. If you don't have one with you, you can Google this app and then download it. It's called Calculate 84 and it should be free, and it basically mimics a TI-84. If you don't have that, just follow along, but it's important to be able to use the calculator to do these things because it's all you can use on the SAT and the AP test. So what you're going to start off doing is you're going to take your calculator and you're going to press y equals up on the top left. And under the y equals category, you are going to type your function. If your function has a numerator and a denominator, so if it's a rational function, you need to make sure to use parentheses because the calculator always takes into account order of operations. So if you don't have parentheses, it won't calculate it correct. So I'm typing in the numerator with I'm typing in the numerator with parentheses, and then I will type in the denominator with parentheses too. So when you've typed that in, this is what you should have. We are trying to find the limit of x plus 1, the square root of x plus 1 minus 2 divided by x minus 3. And in order to do that, we need to figure out what the y values are as x gets infinitely close to 3. And so right now the graph looks like this, but I can't really tell exactly what's happening at 3, so I'm going to change my window set so that I can zoom in a little bit more. So if you press window, again at the top left, your x-min right now should be set at -10. I'm going to change that to 2 because that's just a little bit closer, a little bit smaller than 3. And then I'm going to change my x max to 4 because that's a little bit larger than 3. And then I'm going to press zoom, and I'm going to find zoom 0. I can also just press 0, but that says zoom fit, and it'll basically just fit the new graph to the bounds that we just put in. So I'm going to press enter. Oh gosh, this is embarrassing. Okay, well, if you have the free app, then you're going to get some ads. So I'm going to go ahead while this happens, and I'm going to label my graph over here because I'm trying to figure out what happens at 3. And so I'm going to put 1, 2, 4. So basically, I'm going to end up like graphing this over here. But that's what's going to happen while we watch King Robert's royal match. You guys can skip through this. I know that I can't, but here we go. Okay. Sorry, I didn't know that they had that, but I guess that's what the free version does. So after I press zoom fit, this is what my graph looks like. So if you look over here, the y values are really, really small. They go from 0.238 to 0.273. So I'm going to label this graph, and I'm going to do it by 0.1. So 0.1, so 0.2, 0.3. And I can see a little bit of what's going on, but one way that you can tell, not just looking at it, is if you press trace, it will put a point on your graph, and that's already there. And at the very bottom, if you guys can tell, there's a little thing that tells you what the x and y values are at every point. So I'm going to take my cursor and I'm just going to press it to the right, and I'm just going to watch what happens as that x value gets closer to 3. So as that x value gets closer to 3, my y value is always at 0.25 if you look, and it's actually getting smaller and smaller. It went 0.25265 to 0.25227. We're still getting closer. We're getting closer, and so it really looks like from the left side of this function that it's getting closer to 0.25. So now let's see what happens from the right side. So we're going to approach from the right side. So I'm at 3.4, and I'm going to now move my cursor left. And we're at 0.24 still, getting closer. But it's getting really close again. We're at 0.2486, 0.24895. It's getting really close to 0.25. And so what we can say is that the limit as x approaches 3 of x plus 1 minus the square root of x plus 1 minus 2 divided by x minus 3, it is going to be at 0.25. And this is just an estimate. We only know for sure really what a limit is if we use algebra. And so it looks like it's getting closer. We can assume that is. And then if I draw my graph, it really just kind of looks like this. We don't need to do the whole thing. We're just concerned about what's happening right there. So the answer to that one is 0.25. We're going to do this again in a second, but you're welcome to try this by yourself, One thing I want to let you guys know is sometimes these graphs are using the calculator is a little finicky, and sometimes you press a button that like messes the whole thing up. So one thing I always do, if something happens that's wrong with my graph, I always just reset the calculator, and that takes it back to like the opening settings. So to reset your calculator, if you ever want to do this, if things are going wrong, I press second, and then at the bottom I press the plus sign because it has that little blue memory, and then I just scroll down to reset. I press all RAM and then reset, and now my calculator's reset, and so it's like back to the way that it started, and that's really helpful. But I'm going to go on to the next one. Feel free to try it by yourself. I'm going to type in cosine 1 divided by x. I'm not using parentheses for that because there's only one operation there. And then I'm changing my window set because as we're trying to find the limit as we approach 0, so I'm going to change it to -1 to +1. And then I'm going to press zoom 0 again. Oh my gosh, we have to watch another ad, so please just skip this. You don't have to listen to me talk, but just skip this ad because there's nothing I can do about it as we wait. Maybe I'll pay for the non-ad version. But as we do that, I'm going to label my graph. Okay, we're back. So this is what my graph looks like. And I can kind of tell what's happening here, so I don't necessarily need to press trace. But as I press trace, if you look at these y values, if you keep going, you're noticing it goes from 0.9681, 0.985, like it's just jumping up and down, up and down, up and down. So this is an example of a function that's oscillating. And you can just tell based on that. We talked about this in the last note. So this answer does not exist. As we get closer to 0, it's oscillating, so it doesn't exist. I'm still going to draw the graph. I'm just kind of going to draw it like that. It is bouncing between basically like -0.9 maybe. I don't know. Doesn't matter, but that's it. Don't put your calculator away, but we don't really need it for the next part. I'm just going to let it be there on the side. So this next one, we're going to move on to estimating limits using tables. And the process for estimating a limit using a table is really similar. You're going to look at where the y values go as you approach the x value from the left and the right. So sometimes we have a table of the function rather than the graph of the equation. So this is what we'll do. So example 1 says estimate the limit as x approaches 2. So we don't have a 2 value on our table, but we are getting infinitely close to 2 because we're going from 1.9, 1.99 to 1.9999. So this is where 2 would be, and it doesn't matter that we don't have it because from the right it's also approaching 2. And so as I look from the left, I'm going from 0.2564 to 0.2506 to 0.25001. So I'm going to estimate that as we approach 2, our function is getting closer to 0.25 from the left. So let's check from the right. 0.2439, 0.2494, so it is getting bigger, to 0.249999. So that's also approaching 0.25. And so because the left and the right hand limit are the same, you can write, and I want you to practice writing this out, the limit as x approaches 2 of, this function says it's f of x, that equals 0.25, and it's just an estimate, but we can still use the equal sign. Let's do the next one. So this one says estimate the limit as x approaches 7. So 7, we do have it. It says that 7 is undefined. That doesn't mean there's not a limit there. That just means that the point doesn't exist there. But we can still approach it even though there's a hole in the graph. So as I come from the left, so those are the values smaller than it. So as I come from the value smaller than 7, it looks like I'm approaching, it's kind of hard to tell, but it looks like it's negative 1.925. The reason I'm saying that is because if you look from the right, it is at negative 1.9248. And so I'm going to estimate if it's negative 1.925. Sorry about that. But if you were to say -2 or like negative 1.9, I would accept that. It's an estimate. And so sometimes it's going to be just a little hard to tell. That's why we're going to learn an algebraic method at some point. But I'm going to write the limit as x approaches 7 of g of x, because that's what it says down here, equals negative 1.925. We will do one more. Feel free to try it on your own. So this one says estimate the limit as x approaches 5. So the smaller values, if we're going 4, 4.9, 4.99, that looks like it's approaching, I would say 3.68. This one looks like it's approaching 3.68 as well. But you do notice that g of 5 is 6.37. So this is an example where the limit and the point that does exist aren't the same thing, and that's okay. So I'm going to write the limit as x approaches 5 of g of x is 3.68. But if you want to know the difference, g of 5, the function's value is 6.37. So the function's limit is 3.68, but its value is 6.37, which means that your graph would kind of look like this. There'd be a hole, and then there'd be like a filled-in point above it. Okay, we're going to make our own tables in a second, and that's why we still have our graph open. But first we want to talk about what makes a table good and what makes a table not good, because that's what we'll need when we actually create our tables. So all the tables below will help us find the limit, but one of them is best, and why? So let's start with A. A, we are trying to find the limit. Also for this one, we're trying to find the limit. I don't know if it wrote down anywhere, but we're trying to find the limit as x approaches 2 of f of x. So we're looking for as limit as x approaches 2 of f of x. So I go here, I find 2. But there's a difference in this table than all the other ones, and there's no decimals anywhere in the x values. So yes, we are approaching 2 from the left and the right, but we're not getting infinitely close to it. We have no 1.9s or 1.99s or 2.001, etc. So I'm going to say that this one probably isn't going to be our best because the x values are not infinitely small. I'm going to say not small enough. So you want some x values that are like 1.9, 1.99, because that just gets you more of an exact answer. For this one, I can't tell if the function's going to be approaching 2.9 or is it going to end up approaching 3.25. I really just can't tell. The next one, we have small enough x values. If you look, we have 1.9, 1.99. This is where 2 would go. Everything really just looks good with this one, so I'll come back to this. Maybe this is our answer. C is our next one, so 2 would be right here, and then the x values are 2.001, 2.01, 2.1, 2.25, 2.53. So there is a problem with this. Maybe try to think about it and pause this, but if you can't see it, we only have the x values that are greater than 2. So for this one, we would only be able to figure out what is the limit as 2 approaches from the right side. We only could figure out the right-hand limit. And to figure out a limit, we need to know what the left and the right-hand limit is. And then the last one is the same problem, but it's the opposite. We only have the x values as, or we only have the y values as the x values approach 2 from the left side. And so in order to figure out a limit, we need both sides of the data. So B is our ideal one. There's nothing wrong with B. It has small enough x values. It's approaching from the left and it's approaching from the right side. So here are some three important aspects of a good table for approximating limits. First, you need to approach from the left and the right side of the y value. This is kind of like obvious. This is how you create a table, but your x value should always go from smallest to largest. If you look at all these tables, they go from the smallest value to the largest value. And if you don't do that, you're not going to be able to tell what the limit is. But that is something that we kind of already do. We should know that when you make a table, you do it from the smallest x value to the largest. And then finally, you're trying to get infinitely close to the x value you're approaching. So you need to use decimals. If you don't use decimals, you're probably not going to get the right answer, or you're not going to get as exact of an answer as you probably can. Now, on to the table. So we're going to create our own tables, and we could do this using skills that we already have, but the calculator really allows us to do this quicker. And so here are the steps to creating a table, and I'll go over them in a second. But whatever function you're using, you're going to put that in for y equals, just like we did when we were graphing. So I'm going to start with that one, and I'll kind of walk you through these. So this next one, it says set up a numerical table of values that get arbitrarily close to 0. So basically it's asking what is the limit of e to the x minus 1, sorry, I should write that differently, minus 1 divided by x as x approaches 0. So that's what it's asking. And so we're going to set this up, and then I'll go back through some of the instructions. But if you look here, I have 7 places to put x values in. So I'm going to put 0 right in the middle. And then I'm going to pick out my x values, and then I'll go back to the instructions right there. So I'm going to choose numbers that are slightly smaller than 0 and slightly larger. So I'm going to start with, and when I do this, I almost always use to the thousands. So when you pick your numbers, you want them to go to the thousands place. So if you remember like 1.9, this is the thousandths place right here. This one's the 10th, 100th, that's the thousand. So if I can, 100th is sufficient, but 1,000th is always better. So when I make this, I'm gonna do 0.001 because that one is to the thousandths. Then I'll do 0.01 and then 0.1. The left side is sometimes a little trickier, but it's not too bad. I'm gonna do negative 0.001, negative 0.01, negative 0.1. And if you look, that is from smallest to largest x value. So once I got that, now I'll go back to here. So I'm going to start by typing in this function. And I have to use parentheses because the order of operations would make you do 1 divided by x first rather than e to the x minus 1 divided by x. So I'm going to type in e to the x. To get the e to the x, you press second natural log, the ln, minus 1 divided by x. And then I'm going to press second window, and that's going to take me to this table setup. And what that is going to do is right now, if I click on table, it's choosing all these x values for me, and none of those are arbitrarily close to 0. I mean, -1 is close, but that doesn't help us. And so if I go to second window, that will allow me to change my independent from and independent means x value, auto to ask, which means I can pick the x values that I want the calculator to generate a y value for. So if I go to second table, I'm just going to type in these x values that I just put on my table. So I'm going to type in negative 0.1. I'll type all of these in to put all of them back on my table when I'm done. And I'm just pressing enter. So I press your x value and then press enter. Okay, now I'm going to type those all in, and I'm just going to write them to the nearest thousandths place, and I'm going to round if I have to. So this is going to be 0.952, 0.995. This rounds to 1. This is error, so that means the point doesn't exist there, which you can tell because if you divide anything by 0, it's not going to exist. 0.001, 1.005, and 1.052. So as we approach from the left, it seems to be getting closer to 0 or 1. As we approach from the right, it seems to be closer to 1. So the answer to this one, our estimate, is the limit as x approaches 0 of f of x is 1. There's one more for you guys to do, so try to do it by yourself. I'm just going to keep talking, so pause this if you're trying to do it by yourself. Sorry, it didn't get filled in right here, but this one is actually the first one that we did with the graph. So the answer should come out to be 0.25. And we know that because we did it with looking at the graph rather than the table. So I'm going to go ahead and do this one. Feel free to get started. Okay, that's it. If you look at this, I feel even better about our answer earlier. The limit as x approaches 3 of f of x is 0.25. So that is it with the notes today. If you have any questions, send me an email or write them down and we can talk about them in class.